Hey guys, my name is Kevin Carr. Today we'll be answering the basic calculator 2 question number 227 on Leetcode. Today we're only going to be solving it in Java, but I'll be able to give you two solutions for this problem. So one involves using a stack and the other one is a little bit using less space without the stack, but essentially doing the same thing. So the problem statement for this problem is given a string s which represents an expression, evaluate this expression and return its value. The integer division should truncate towards 0. So the good thing about Java is with its strongly typed values, we don't have to worry about this division. If we were solving this question with Python, we would have to worry about decimals and floats when things are getting divided. Thankfully for this question, it's going to be relatively straightforward. So for our first solution, we'll be able to solve it in on time and on space. The on space comes from using a stack. So why is a stack important for this type of question? If we look at the actual question prompt, we'll see that it says, evaluate this expression. Usually with these string questions, you can think about a string as a sequence of characters. And especially when you're evaluating it, you can use stacks to implement certain rules. So in this case, the ordering of this string is important. So we would want to first multiply 2 by 2 before we get to 3. So if we were to go through this stack, let's just imagine from left to right, the stack bottom is at the left. We would put 3 at the left or bottom, and we would put 2 there. And once we get a division or multiplier, in this case, these last two characters, multiplier and 2, we would times those. So 2 times 2. So we'd pop that top item or the right item and then put the result on top. At the end of that processing of the string and evaluating it, we would just iterate through every single element on the string and add it together. So in this case, it would eventually equal 7. So let's write that out in code. So one thing we want to do with these particular problems is make sure that we have some type of base case or error catching or edge case catching. In this case, we want to make sure that the string itself is not null or empty. And the good thing with string methods is that they have a built-in method for you to check if something's empty. If so, you can just return a 0. So how do we exactly create a stack? So thankfully too, there's a built-in type called stack that we can build using this stack keyword. I'm just going to call it stack to make it simple. So our stack's will be full of these integers because essentially we want these numbers inside the string in that stack. And then we're eventually going to add it. And then as a little note for Java, we always, most of the time, want to make sure that the inner types are capitalized to its more, I wouldn't say class-based, but non-primitive types. Okay, so we're going to want to have a way to see what the current operator is and then also what the current number is. So we want to initialize it first towards a current num. So let's just say that's 0. And then the current sign, which would be plus at the start. So then we're going to iterate. And go towards the string length. At each part of the string, we're going to check if something is a number or an operator. And we're going to see what the current character is. So with strings, there's a built-in method called .char@, where we can take the index and find that character. So I'm just going to call it cur ch for char equals s.char@, and then the current index. So the cool thing about characters is they also, like with strings, have built-in methods. So we can see if something is a digit. If so, we want to add it as the new current num. We want to make sure that we can evaluate it So for this current character, if it is a digit, we want to subtract that. So if it's 9, we want 9 minus this base case of 0, and that'll actually give us the ASCII table number. So if we actually look at that, ASCII table C plus numbers, the reason we're subtracting it is because we're actually trying to find the numbers. So for example, we see that the numbers start at 48 and end at 57. So essentially, if your current character is 9, we want to do 57 minus 48. And make sure that's a number we can apply. If it isn't a digit, we either have an operator. Oh no, we have an operator or a white space. So we also want to check for that. So we want to make sure that something is not a digit. And something is not a white space. And you can see all these built-in methods you have for the character type. We also want to make sure that we're not at the last number. Or if we're at the last number, then we just add something. And then within this logical block, we want to make sure that we can handle every single operation or sign. So in this case, if our character or sign is minus, we want to subtract that or add that to the stack. So in this case, we're going to be adding a negative number. Else if the operation or operator, sorry, equals the plus sign, then we're going to add to the stack the current num, and then it's going to basically repeat the same process. So if we have a multiplication sign, the cool thing is that with these higher priority multiply and divide, we actually want to take the most recent number from the stack and then multiply or divide it. So you'll see it here. We'll actually push to the stack the result of the top item times the current number. And the same thing with a divisor. And I misspelled this operator. So stack.push, stack.pop divided by current num. So the cool thing is, in comparison to Python, for this particular problem, we don't have to worry about it rounding down because since we have an integer, it's just going to remove the decimal portion of an uneven divide. So for example, 3 divided by 2 is going to round down to 1 because our current num is 1, or the integers are in the stack. So after we're done with all of these processing of the operators, we're going to make sure that the operator is equal to the current character, and the current num is reset to 0. After we're done with this for loop, we're going to take or create a result, and then just iterate through the stack. So while the stack is not empty, we're just going to add to the result the top item. Whether it's negative or positive, it's going to give us the end result. When we're done with that, we're going to return that result. And as you can see, it is successful. And the cool thing is that we use a stack. This makes this time space complexity O n time, O n space, because we use a stack that is basically goes through the whole string. We can actually make this a little bit simpler. So almost similar to a Fibonacci problem where you can kind of do it dynamically. Instead of using a hash table or dictionary to store results, we can actually just use 2 pointers to track these results. Similar to this, we don't need the stack. We can actually just use a current number and a last number. and that would reduce the space complexity to O1 or constant time. So last num equals 0, and then result equals 0. And then I would just remove this. So we basically just do the same thing for the most part, but except in this block, now we do a little bit things different. So instead of using a stack, we just use the current number and the last number. And actually accidentally have my insert there. And we can actually combine the operator minus and plus. Okay, so that removes 2 of those. So that can be moved down to you just adding the number, and then you doing a ternary operator in order to reset that last num. So if the operator equals the plus character, then we'll have the current num, else negative current num. And then if we multiply, instead of using this, I think it's last num equals last num times current num. And the same thing with this, except we multiply. Oops. So now we just divide. So last num equals last num divided by cur num. Again, the characters reset after these operators are evaluated, and the cur num is reset. And all we have to do at the end of this is add the result of the last num and then return that result. Oh, and there was just a little bit of issues here. Oh God, okay, come on. And I forgot the semicolon here, so just be careful with that in interviews. And basically we had the same time complexity, but we use less space. So this is how you solve the basic calculator too. Thanks guys for joining, and see you guys in the next video. Cheers.